It begins the same way every time. The day is over, the lights are low, the house has gone quiet around you. And somewhere between the end of the evening and the beginning of sleep, something shifts inside you. A pull, a pressure, a sensation that arrives not quite as hunger and not quite as craving, but as something that feels urgent and specific and almost impossible to ignore. It does not ask for a salad. It does not ask for water. It asks for something dense, something sweet, something salty, something that delivers an immediate and unmistakable sense of relief the moment it reaches your mouth. And what is remarkable, what most people never stop to consider, is that this nightly pull is not a weakness. It is not a failure of discipline. It is a message. A signal broadcast from deep inside a body that has been running all day on a complex and finely balanced set of systems, and that is now in the darkness of the late evening trying to tell you something important in the only language it has available. Your body does not speak in words. It speaks in chemistry. And when the chemistry is off, when something is depleted, imbalanced, or quietly dysregulated, the signal your brain receives is not a precise report. It is a craving, a pull towards something that, in your brain's deep evolutionary library, has historically been associated with solving the problem. The question is not whether to listen to the craving. The question is whether you know what it is actually saying. To understand what is happening inside you on those nights, to truly follow the signal back to its source, we need to travel into the body at a very specific moment. Not the moment the craving arrives, but the hours before it. Because the story of why you want chips and chocolate at 11 p.m. does not begin at 11 o'clock. It begins at the cellular level, hours earlier, in the slow unraveling of a system that has been holding everything together since morning. Zoom inward, into the first layer of the story, your blood. Right now, in the hours following your last real meal of the day, glucose, the primary fuel currency of your brain and your muscles, is moving through your bloodstream in a pattern determined entirely by what you ate, when you ate it, and how your insulin system responded. If your day included meals that were balanced, meals that combined protein, fat, fiber, and complex carbohydrates in proportions that release glucose slowly and steadily, your blood sugar has been declining across the late afternoon and early evening along a gentle, gradual slope. Manageable, steady, the kind of decline that your body handles with quiet efficiency, drawing on stored glycogen in the liver to buffer the gap, keeping your brain fueled without drama. But if your day looked different, if lunch was hurried or skipped, if the afternoon included something sweet or starchy without sufficient protein to anchor it, if dinner was late or light or heavy in refined carbohydrates, then your blood sugar curve has not been gentle. It has been a series of peaks and crashes, each spike of glucose followed by a rapid insulin response that clears the sugar from the blood faster than the next meal can replenish it. And each crash leaves a signature in the brain, a whisper of fuel scarcity, a faint alarm signal from the hypothalamus, the small but extraordinarily powerful region of the brain that monitors your internal chemistry with the attentiveness of a control tower managing dozens of incoming flights simultaneously. By the time evening arrives, if that blood sugar pattern has been rocky all day, your hypothalamus is not whispering anymore. It is sending clear directive: find fast fuel. And fast fuel, in the evolutionary library your brain was built from, looks like dense calories. It looks like fat and sugar combined. It looks, in the modern landscape, exactly like the snack aisle. But blood sugar is only the first layer of this story. Travel deeper into the landscape of your stress chemistry, because the evening craving is almost never about blood sugar alone. It is also about cortisol, the body's primary stress hormone, produced by the adrenal glands that sit like small peaked caps above each kidney. Cortisol is one of the most important chemicals in your entire operating system. It is the hormone of activation, of alertness, of metabolic mobilization.
In the morning, it rises sharply, a natural peak that helps you wake, think, and engage with the demands of the day. Across the course of a healthy day, it should decline in a smooth arc, reaching its lowest point in the late evening to allow the body to shift into rest and recovery. But in a body that has spent the day under psychological pressure, deadlines, conflict, digital overstimulation, financial worry, the constant low-level vigilance of a mind that never fully disengages, cortisol does not follow that smooth arc. It stays elevated. It plateaus in the afternoon. It is still running at abnormal levels when the evening comes. And here is what elevated cortisol does in the context of late-night food craving that almost no one talks about. It directly increases appetite for calorie-dense food. It suppresses the satiety signals coming from the gut. It amplifies the reward response in the brain's dopamine system, making the anticipation of food feel more urgent than it would under normal conditions. It also specifically drives cravings for sugar and fat, the two nutrients that, from an evolutionary standpoint, most rapidly counteract the physiological state of stress. Your body is not looking for pleasure, it is looking for chemical rescue. The chips are not a treat, they are, from your adrenal system's perspective, an emergency. Now travel upward, into the brain itself, into the intricate architecture of your reward circuitry. A network of structures centered around a region called the nucleus accumbens, which sits deep within the brain like the heart of a power grid, distributing electrical reward signals through dopamine pathways that extend across vast regions of your neural landscape. This system evolved to ensure survival. It was designed to make finding food, water, warmth, and safety feel rewarding, to encode those behaviors with a chemical pleasure signal strong enough to motivate repetition. In the ancestral environment, this was adaptive. In a modern world where hyper-palatable food is available in unlimited quantities at any hour of the night, the same circuitry becomes something else entirely. Junk food, the specific combination of sugar, fat, and salt that industrial food engineering has refined over decades, activates the dopamine reward system with a speed and intensity that no whole food can match. A handful of chips triggers a dopamine release that is measurably faster and measurably larger than a handful of almonds. A square of milk chocolate delivers a reward signal that arrives in the nucleus accumbens within seconds of the first bite. And in the evening, when your prefrontal cortex, the brain's center of executive reasoning and impulse regulation, is fatigued from a full day of cognitive work, the balance of power shifts. The reward system speaks louder. The regulatory system speaks more quietly. The craving wins, not because your willpower has failed, but because the neurological architecture that could moderate it is running at reduced capacity. The way a ship's navigational system becomes less precise when the crew has been awake for 16 hours. For anyone who wants to understand the full map of what your brain and body are doing in these moments, there is a complete guide called Body Hidden Signals in the pinned comment below. It traces the signals your body sends through cravings, energy patterns, and sleep disruption, and explains what each one is actually asking for at the biological level. It is a resource worth reading alongside what we are uncovering here. But the story of the night craving has a third layer, and this one reaches into a part of your biology that most people have never considered in this context. Travel now into the gut, not to the stomach, but deeper, into the vast microbial ecosystem of the large intestine, where hundreds of trillions of microorganisms are living in a relationship with your biology that is older, more intimate, and more influential than most people realize. This ecosystem, your microbiome, does not just assist with digestion. It produces neurotransmitters. It communicates directly with your brain through a two-way neural highway called the vagus nerve. It influences your mood, your anxiety levels, your sleep quality, and your appetite patterns with a reach and specificity that neuroscience has only recently begun to map. And here is the connection to your evening craving that is perhaps the most surprising chapter of this entire journey. The bacteria in your gut are not passive. They have their own metabolic needs. Different bacterial species thrive on different substrates, and the species that have been consistently fed a consistent diet of sugar, refined carbohydrates, and processed fats develop an appetite for exactly those substrates. They send chemical signals upward through the vagus nerve. They produce compounds that influence the brain's hunger and reward pathways. They are, in a very literal sense, participating in your craving. When you feel an overwhelming urge for something sweet at 10 o'clock at night, part of what you are feeling is the metabolic demand of a microbial community that has been conditioned over months or years of repeated dietary choices to expect a certain kind of fuel at a certain time. The craving is not entirely yours. It is in part a signal from a population of organisms living inside you, organisms that have learned your patterns and are now lobbying for their preferred substrate. This is one of the most remarkable discoveries in modern nutritional biology. The gut microbiome can influence food cravings in real time. It can amplify desire for specific nutrients, and it can do so in ways that feel entirely internal, that feel from the inside like your own hunger, your own impulse, your own need. The borders between your biology and your microbial ecosystem are far more porous than the idea of individual identity would suggest. You are not having a craving. You are experiencing a negotiation between your brain, your hormones, your energy stores, and a microbial civilization that has been quietly shaping your preferences for years.
Now here is the part that reframes everything, because understanding why the craving happens is only half the story. The other half, the part that genuinely changes the relationship between you and this nightly signal, is understanding what your body is actually asking for when it reaches for the junk. And almost every time, when you decode the chemistry beneath the craving, what you find is not a need for the thing being craved, but a need for something else entirely, something specific and addressable that the craving is pointing toward in the imprecise vocabulary of appetite. The craving for sweets at night is, in the vast majority of cases, a serotonin deficit signal. Serotonin, the neurotransmitter most associated with calm, emotional stability, and a sense of well-being, follows a daily production cycle that is intimately tied to both light exposure and carbohydrate intake. Serotonin is synthesized from an amino acid called tryptophan, but tryptophan cannot cross the blood-brain barrier efficiently in the presence of competing amino acids. Carbohydrates, by triggering insulin release, pull those competing amino acids into muscle tissue, clearing the pathway for tryptophan to travel to the brain and be converted into serotonin and, subsequently, into melatonin, the hormone of sleep. Your body's craving for carbohydrates at night is, in a very real neurochemical sense, a craving for serotonin, for calm, for the chemical precursor to sleep. What it needs is a small strategic carbohydrate intake, something like a banana, a small portion of oats, or a handful of dates, not a bag of chips, which will deliver the carbohydrate signal buried inside so much salt, fat, and additive stimulation that the net effect is the opposite of calm. The craving for salty food at night, for chips, for crackers, for anything with that specific mineral sharpness is almost always a signal from the adrenal system. Salt craving in the evening is one of the most reliable indicators of adrenal fatigue, a state in which the adrenal glands, depleted by a day of sustained cortisol output, begin signaling through the hormone aldosterone, which regulates the body's sodium and mineral balance. A body that has been under stress burns through sodium at an accelerated rate. By evening, the deficit registers as an urgent pull toward salt. What the body is asking for is not processed sodium, it is minerals, specifically the complex mineral profile found in things like mineral-rich broths, olives, sea vegetables, and fermented foods.
The craving is pointing toward a genuine physiological need. The junk food is simply the most available and most immediately rewarding delivery vehicle for a mineral signal that the body cannot articulate more precisely. The craving for fat, for the dense, creamy, rich quality of cheese or nut butter or chocolate, is frequently a signal about cellular energy. Fat is the body's deep storage fuel. After a day of sustained mental work, the brain, which runs almost exclusively on glucose during active cognition, begins to shift its fuel preferences toward ketone bodies, which are produced from fat metabolism. A craving for high-fat foods in the evening can be the brain's version of reaching for its secondary fuel source, particularly if the day has been cognitively demanding and glycogen stores are partially depleted. What the body is pointing toward is not processed fat combined with artificial ingredients. It is high-quality fat, avocado, walnuts, full-fat dairy if tolerated, a small amount of dark chocolate, which carries not just fat, but magnesium, one of the most commonly depleted minerals in the body and one of the most important for nervous system regulation and sleep onset. Magnesium is worth pausing on, because if there is one nutrient whose deficiency maps most consistently onto the pattern of late-night cravings, poor sleep, evening anxiety, and the kind of restless mental energy that keeps people reaching for food when what they need is rest, it is magnesium. Magnesium participates in over 300 enzymatic reactions in the human body. It regulates the GABA receptors in the brain that produce calm. It modulates the adrenal response to stress. It is essential for the proper function of insulin signaling, which means its absence makes blood sugar regulation less precise and more prone to the volatile swings that produce late evening hunger. And it is depleted by the exact conditions most common in modern life: chronic stress, high sugar intake, alcohol, poor sleep, and the consumption of diuretic beverages. The craving for chocolate at night, one of the most reliable and widely reported evening food compulsions, is, in a significant number of cases, the body's attempt to reach a dietary source of magnesium through one of the few foods in the modern pantry that contains it in meaningful concentration. Stand back for a moment and look at the full picture of what has been described here. A nightly craving for junk food is not one thing. It is the convergence of multiple biological signals from the blood sugar system, the adrenal system, the serotonin production pathway, the gut microbiome, the mineral status of the cells, the fatigue state of the prefrontal cortex, all arriving simultaneously in the brain's reward center and being interpreted as a single urgent pull toward the most calorically dense, the most stimulating, the most immediately rewarding option available. The body is not confused. It is overwhelmed with needs and reaching for the fastest available solution. The problem is not appetite. The problem is the gap between what the body is asking for and the options it is being offered.
And here is the adaptation that changes everything. When you begin to meet the actual needs, when you stabilize blood sugar through balanced meals eaten at consistent intervals, when you reduce the cortisol load through deliberate stress regulation, when you shift the gut microbiome by feeding it fiber and fermented foods over weeks and months, when you restore magnesium through diet or supplementation, when you give the serotonin pathway what it needs through adequate protein across the day and a small, clean carbohydrate source in the evening, something shifts. Not overnight, not in a single decision, but gradually, across a span of weeks, the nightly craving loses its urgency. Its edges soften, its specificity changes. The pull toward chips fades because the signal that was driving it has been addressed at the source. The body is no longer sending a distress call at 11 o'clock at night because it is no longer in distress. It has been met earlier in the day at the level of its actual needs. And what was once a nightly battle becomes something quieter, something more like genuine hunger at appropriate times and genuine rest when rest is needed.
This is what makes the study of cravings so much more than a conversation about willpower or self-control. It is a conversation about biological literacy, about the difference between hearing a signal and reading it, about what becomes possible when you stop treating your body's communications as interruptions and start treating them as information. The craving is not the enemy. It is the most honest thing your body does. It is reaching toward you across the gap between what it needs and what it has, using the only language available, the language of appetite, of urgency, of pull, and asking you to listen more carefully than you have before. The extraordinary truth at the center of this story is that the body never stops communicating. It communicates through cravings and through silence, through energy and through fatigue, through sleep and through the specific quality of waking. Every signal is a report from a system working hard to maintain the balance it was designed to keep. The nightly craving for junk food is not a failure of character. It is a dispatch from deep inside a living system, intelligent, ancient, and remarkably specific in what it is asking for. What we have traveled through today is one passage of a much larger conversation, the story of a body that has been sending you signals every day through hunger and craving and energy and mood, in a language that most people were never taught to read. The Body Hidden Signals Guide in the pinned comment below is a map of that language. 40 signals, 40 explanations, organ by organ and system by system. The next time your body reaches for something in the dark, you will know what it is actually saying, and you will know exactly how to answer it.